Actually, there are a lot of people that are joining in.
Let's start the data kupera.
Right. I've given you the option. The two people also waiting. Yeah. Right. When you're doing statistics, right, there are softwares that you would use if you're at work. You wouldn't use the calculator because you will be dealing with a vast of data set or volume of data set, which might be either big and in terms of size or in terms of the dimension. So you wouldn't use your calculator to do all those analysis. So there are a lot of softwares that you can use for you to analyze data. We've got SPSS, which stands for statistical packages for social sciences. We've got Excel, it does also statistical analysis. We've got R, it does statistical analysis. We've got eViews, we've got SAS, we've got Python. There are a lot of softwares that you can use to analyze data. But for this particular course, I think I limited myself to SPSS and R, where SPSS, most of the people, they tend to use it because it's flexible.
Need the permission from Blackboard.
Hello, can you mute? You guys can mute. Can you mute your mic? If I realize that, can you mute your mics? If I realize that you haven't muted, I will remove you from the lesson. So now, for today's lesson, we're going to focus on SPSS, on how you can enter data and how you can analyze. So I was saying in this lesson, I'll focus on SPSS, on how you enter the data and how you analyze. So there are two windows in SPSS. There is a data viewer and a variable viewer. So when you are entering the data, you have to enter the variables first that you have. So we had a question, I think, let me share the question. Yeah, just the question. Right, with the question in tutorial number 1, right, the last question, which is number 6. It says, redo question number 5 above using SPSS and compare your results. So question number 5, it said random samples of 7 pairs of observations were recorded on 2 variables, which is X and what? And Y. The data is shown below. So A, you asked to construct a scatter plot and comment on the what? On the relationship. B, you asked to calculate the Pearson correlation coefficient and comment. And then C, you asked to test the 5% level of significance if rho is equals to 0. D, calculate the Spearman's correlation coefficient and test if rho S is equals to 0 using alpha is equals to what? To 0.05, sorry. So now we can go to SPSS and try. So we've got 2 variables, which is X and what? And Y. So we would have to enter X and Y in SPSS. So this is our SPSS. And I said you've got a variable viewer and the data what? Viewer. I'm shifting and showing you the variable viewer. There's a column for name, type, width, decimal, label, values missing, columns, align, measure, and row. So initially you enter in the first box. So you with variable what? X, right? You enter variable X and then you say enter, or you click the right click on a laptop. So the type of variable that you have in this case, remember X, it's numerical. So I will leave it as it is, it's numerical, because from the data that we have, it's numerical. And the other question is, what is the width of the number? Usually this width works with what are called strings, but in this case we're not dealing with strings. I'm sure in other courses that you're going to be doing, if you're going to use a string, you would have to define the width, right? And by default, they give you what, a width of 8, and then the number of decimal places that you might be having. And by default, now they're giving you what, 2 decimal places, and you can label. So there are different functions of these what do you call icons. But for now, for this course, I think everything that is considered by default, it's okay. I'm sure you will learn more about it in other courses. We want to focus on how you use SPSS in recreation. So the next variable that you got, that will be y. You enter y. So all the variables that you need, it's x and y. So you've entered them in the variable what? Of viewer, and then you go to what? To data viewer. That's when you now capture what? Your information that you have on the SPSS, right? So I think we have got data that is for x. We have got 65, right? So I'm gonna enter 65, then 57, 55, then 38. So I skipped 38. The next is 29. Next 43. The next 49. And enter the values what for y, which is what 58, 81, 56, 23, 34, 38, then 30 what 37. So you would have done that by entering the data set. So after entering the data set, the question was first to come up with a plot. So here after we have entered the data, now you have to analyze. There's the graph part, right, which shows you whether if you want a scatter plot. So you go on graphs and click our dialog box, and then you go to scatter plot. So there is a simple scatter plot, matrix scatter plot, but our focus is on on a simple scatter plot. So you define one that you want. Then since we talked about a situation where we've got a dependent variable and an independent variable, we have to draw the independent variable where it's supposed to be. In this case, it's selected x. So this x has to go to the x-axis. You pick the y goes to the y-axis. So there are a lot of options. Maybe you want to give a title to your graph. You can do that. You can play around with these options and see what comes out from those options. But basically, you can draw x, then you draw y, and then you can come up with the scatter plot. Can you see the scatter plot? Hello?
Yes.
Can you see this? Can you see the scatter plot?
No, not yet.
No, not yet.
You see the data only.
Yes.
Let me stop sharing it because it's in another window, which is the output window. So I'm sure now you can see it.
Yes, we can clearly see it.
Yeah, so that's the scatter plot. So you go to graphs, right, and then you go to scatter plot, and then you come up with the scatter plot. So now you can comment what's the relationship between x and y. So we can see that there is a positive linear relationship between x and y. So we would have done the scatter plot. But you can change these labels. You play around with SPSS, you can change these labels to x and y. Probably x it was age, and y probably it was weight. And what happens is age increases to the weight. So that's the scatter plot. So you need to be able to comment on it. It's a positive linear relationship between x and y. So let's go back to the data and then do the other questions. So the other questions, you're supposed to come up with correlation, right? So the correlation, you go where it's written analyze, right? And then you go where it's written correlate, right? You select bivariate, which means bi means two. So you would click where it's written bivariate, and then you pick the variables all that you want, right? And then below there's an option. By default it gives you what Pearson. So in this case we wanted also the spearman. So you only click the spearman. You only click the the spearman and the Pearson. So I'm sure you still remember when you talked about I think you did this when you're doing applied statistics 1, that there's a two-tailed test and a one-tailed test. So if you're dealing with the two-tailed test, you select two-tailed. If you're dealing with one-tailed, you select one-tailed. So it depends on your hypothesis, right? But our hypothesis, I'm sure when we did the tutorial 1, we say H0 rho is equals to what? To 0. H1 rho is not equal to what? To 0. That means it's a two-tailed test. So I have selected the Pearson and the spearman, and then you click what? You click OK. It gives you outputs, right? So what it does in output, it gives you the correlation between X and Y, right? It gives you what is called the p-value, or what we call the probability value. So you need to be able to interpret those values. For example, let me show you the table now that contains the results. So the table above here, it shows you the results of of the Pearson's correlation, and the table below shows you the table for the Spearman's rho. So there are two tables. You're looking at Pearson and Spearman. Now, for you to understand this, it's the correlation that you are concerned about. It's X and Y, not X and X. That's why you would see on this, it's more of a matrix, right? You see the correlation of X and X. It's 1, right? So you're not concerned about that one. We're concerned about the correlation between X and Y, which is 0.753. That's the correlation that you want. So 0.753, that's the correlation that we have. So now if we say R is equals to 0.753, and then below the correlation coefficient, that's the p-value, that's the probability value. So the rejection criteria of the p-value, it's always the same throughout. In every type of analysis, you should remember the same rejection criteria that I'm going to state now. Wherever you go, that's the rejection criteria. So we reject H0 if the p-value is less than 0.05. We reject H0 if the p-value is less than 0.05. Remember, our hypothesis would have said H0 rho is equals to 0. H1, which is the alternate hypothesis, rho is not equal to 0. Then we would write the rejection criteria. We reject H0 if the p-value is less than 0.05. So in our case, our p-value is greater than what? 0.05. So what do we do? In this case, we fail to reject H0. So if you are failing to reject H0, what are we saying? We are saying rho is equals to what? To 0. That means the correlation coefficient is statistically insignificant at 5% level of significance. Let me repeat what I've said just now. I said our hypothesis H0, which is the null hypothesis, will be rho equal to 0. Our alternate hypothesis will be rho is not equal to what? To 0. Our rejection criteria, we reject H0 if the p-value is less than 0.05. So in our case, what is our p-value? It's 0.051, which is actually greater than what? The 0.05. So we are going to fail to what? To reject H0. So if we are failing to reject H naught, what are we saying about rho? Rho is equals to 0. So if rho is equals to 0 or the correlation coefficient is equals to 0, we are saying the correlation coefficient is statistically insignificant. The one that we have obtained is 0.753. Is statistically what? Insignificant. So you should, if given a table of Pearson correlation, we are supposed to interpret one, the correlation coefficient, which is 0.753. We are going to say there is a strong positive linear relationship between X and Y. That's how you interpret the what? The correlation, Pearson correlation coefficient. And the p-value is less than, it's greater than 0.05. So if it's greater than 0.05, we fail to reject H naught, and we conclude that the correlation coefficient is statistically insignificant. Then now we go to the Spearman's correlation, right? So the Spearman's correlation, it gives us the same value. We have to get the correlation coefficient and also the what, the p-value, right? So we are saying the Spearman's correlation coefficient is 0.865. So if it's 0.865, right, we have to interpret it and say that there is a strong positive linear relationship between what, X and what, and Y. There's a strong positive correlation, linear correlation between X and Y because it's above 0.75. Then now you write the hypothesis again. Now, if you want to test whether that Spearman's correlation is statistically significant, your now hypothesis will be rho subscript S is equals to 0. So that subscript S stands for the Spearman, and the alternate is rho S is not equal to what? To 0. We reject H naught if the p-value is less than 0.05. But our case, this p-value, which is 0.012, it's actually less than, right? That means we are going to what? To reject H naught and conclude that the Spearman's correlation is statistically what? Significant. Yes, these values, they should be different because we are using different approaches, right? The other one, the Pearson correlation doesn't consider the rank, while this Spearman correlation considers the component of the rank. That's why these values will be different. So this was what was expected in for you to do in tutorial number what? Number 1. So is there any question on the scalar plot? Pearson's correlation coefficient and Spearman's correlation coefficient. Any question before we do tutorial, the questions that are in tutorial 2?
See, can you please repeat on the rejection criteria?
It's always the same. We reject H naught if the p-value is less than 0.05.
For both the Spearman and the Pearson's correlation coefficient.
You see, it's still the same, it doesn't change. If the p-value is less than 0.05. If p-value is less than 0.05, we reject H naught.
Okay, thank you.
So if there are no questions, can we move on to the next tutorial, which was tutorial number 2? Yes.
Spearman.
You said what? Spearman.
Pakutshala to change comment.
Okay. I said the Spearman's correlation. We have got the correlation, which is Spearman's correlation, which is 0.865. All right. So we have to interpret that value by saying it's a strong positive linear correlated between what? X and what? And Y. So there's a strong positive relationship between X and what? And Y. Now, for us to do the hypothesis testing for the Spearman, right, you have to look at the p-value, which is 0.012, right? So in this case, what you do is, what's the rejection criteria? We reject H0 if the p-value is less than 0.05. But in our case, our p-value is actually what? Less than 0.05, all right? Which implies that you are going to reject H0. What it implies is that our row subscript S is not equal to what? Is not equal to 0. Therefore, we are saying the correlation, the Spearman's correlation coefficient is statistically what? Significant. So if the hypothesis is equal to 0, we are saying the correlation coefficient or the Spearman's correlation coefficient is equal to 0. That means it's statistically insignificant. But when it's not equal to 0, then we're saying it's what? Statistically what? Significant. So now, any other question before I go to tutorial number 2? I hope you guys, you did tutorial number 2. I'm just doing so that you guys, you can learn. But I think I tried to be available on, was it Monday? And most people, they never showed up. I thought people, maybe they did the tutorial by themselves, which was excellent. So we'll meet you on the assignment. So now I'm entering a new data set. So when I'm entering a new data set, can you see my screen or you see the results? Let me share the screen. So now, suppose I need to enter another data set, right? I have to go to File and open a new a new window where I can be able to enter my new data set. So question number 16, we've got blood pressure and age, right? So now let's enter the variables. We go to variable view, then I enter X, I enter what? Y, right? So then I go to data viewer so that I can enter my data. So our X, we've got 20, yes, 45. What's on my screen? I see.
Just seeing the odd one.
What about now?
Yes, we can now see.
Okay, so I was entering is 20, 45, 29, 29, right? And then 67, 56, 56, 47. Next it's 38. Then next it's 50. Now I can enter the Y, which is 116. 138, 132. So I left 10 minutes. I hope I'll be able to finish. If I'm not able to finish, we will rejoin. 162. after 160, is it 162? Yes. 154, 220, 128, and then 142. Right. So what did the question require us to do on that tutorial? Okay. In fact, I used the other question. It says I'm using the data for question number 2 to perform what was required by question 5, right? So use SPSS or R to fit the simple linear regression model for the following data. So the data is just the same, it's only that I changed the data. So now we entered our data, so we need to fit a linear regression model. So we go where it's written analyze, and then there's a section where it's written regression. So the type of regressions, there are a lot of types of regression that you would learn as you go by, but now we are focusing on linear regression. So that's why I had to go to analyze regression and then linear regression. So what is our dependent variable? Our dependent variable in this case is our Y, which is the blood, which is BP, which is the blood pressure, right? So I click Y and then I drag it to dependent. I drag X and then to the independent variable. So there are a lot of things that are in this you can get. These are the things that you're going to be dealing with as we go. We're going to deal with confidence intervals, the R squared, the collinearity diagnostics, the Debye-Watson. So all these are measures of goodness of fit, or that checks the adequacy of the model. So you need to, as you go by, you will see that these things are very important. And we talked about assumptions of linear regression. You should be able to construct some plots so that you can validate how good the model it is. You can have got some savings. There's a lot you can save, different types of distance measures. You can save different types of residuals. We're going to talk about that. I think I introduced you on residuals when I'm talking on and how you derive the beta naught and the beta 1, which is the method of ordinary least squares. Then you've got options where you decide whatever you want to select. But what's key for us, simple, you have to drag the dependent and the independent variable, and then you click OK. When you click OK, you have to go to the output window. So I'll stop sharing and then I'll go to the output window. So on the output window, can you see the output window?
Yes.
All right, so these are the results of the data that I entered, right? So the first table, it gives us the R squared, or the R and the R squared, adjusted R squared, and the estimated standard error. But for now, you're concerned, or the following table, it gives us the ANOVA table. I'm sure those who have read chapter 3 of our notes, they will realize there's analysis of variance for the regression. So that's the part that I will be able to explain after I've given you the audio. So I'll be able to send the audio, and then you'll be able to understand the ANOVA section, which is chapter 3. So if I send the audio, you should be able to do this and understand. Then the last table is the one of coefficients. All right. So this is the one that I want to explain today because that's what we have done of estimating beta naught and beta 1. So in your mind, when you're looking at simple linear regression model, I think you did equation of a straight line, right, at high school, where you used to say y is equals to mx plus c, right? So y is a dependent variable. Your x, that was the independent variable, and your m, you used to call it gradient, right? And now we call it slope. It's probably a change of names, but I think some use slope or gradient. And then c, used to call it the intercept, right? So we are now translating it to y is equals to beta naught plus beta 1 x we were saying our y is our dependent variable, our x is our independent variable. Then we've got beta naught. Beta naught, you will see that it's a constant. So it will be the same as saying c. So beta naught, that's our intercept, right? And then plus beta 1 xi or x1, right? So our beta 1, that's our gradient, because that's the coefficient of x, or the coefficient of the independent variable. So core beta 1 is our slope, our gradient. So when you come to this table of coefficients, you want to pick your beta naught, you want to pick your beta 1, right? So our beta naught in this case, it's that's the constant, right? Or the intercept. So in this case, the constant, which is b, which is negative 10.854. That's our beta naught. And then our beta 1, that's the coefficient of the of x. That is 1.120, right? So that's beta 1. So if you had to write the equation of the model, you're going to say y is equals to minus 10.854 plus 1.205 xi or x1. Or in this case, it's particularly x, not xi. So it's y is equals to minus 10.854 plus 1.205. So this is good in the sense that you work when you be attached, or after you're graduated, you no longer be using the calculators because they've got more memory. So you'll be expected to use softwares to do the analysis. So you need to be versatile and know different softwares that do a particular analysis so that you can address the data that you have. So for now, we are building you on theory, on the theory that we are building, so that you would understand how you apply these things. Somebody says, SPSS, personally, I school, come on, you may type in English. Some of the words are difficult for me to pronounce in Shona. So can you type in English if you want me to address your question? So yeah, as we go on, we'll be interpreting these values as you go on. You realize you'll be getting them as you go on. So if you're given a question, we are practicing, start by doing that on what? On SPSS or R. So I say this is optional. I know some departments like food science and nutrition students, they would use this software, right? So that's why I said even the students from actuarial science or statistics, you may decide to use SPSS. So you can learn, it's optional, but I'm sure for R, it depends on the department, especially science, they wouldn't use that at early stages. For food science students, I would urge you to use this because you probably want to use this when you're doing your dissertations at fourth year or even at attachment level. So any questions, guys, before we end the lecture? The other components that we are going to discuss them as we go. But this was to cover tutorial number 1 and tutorial number 2. So the other aspects, I'm sure you're going to deal with them when you're dealing with what? With other sections. I'm sure we're going to connect again so that we finish our lecture well, because there's somebody who says, given a data, how do you distinguish between the dependent and independent variable? So I think let's join after this the 40 minutes have exhausted, so that I can answer this question. I think now I've got 45 students. I'm sure by that 45 students would have joined. Someone says, I'm sorry, I'm saying the SPSS I got is not opening on my PC. I then try to transfer it to USB, so I do not use the school's computer, but it's still not opening. I think it's a laptop method. Find out what's the problem with the laptop, because some that I gave, you have to install it and open it. You determine the independent variable. Can somebody answer that question? How do you determine the dependent and independent variable? In this question, you've got age, right? And blood pressure that we're doing, right? So the question is, what depends on another? Which variable depends on another? I'm sure you know as you grow older, you tend to have what? Blood pressure, right? If you didn't mute, I can remove you. Hello guys, if you didn't mute your mic, I can remove you this side. I've got that mandate. So mute your mics. I can easily remove you if you don't mute your mic. So I was saying, you've got blood pressure, right? You've got age, right? So these are two variables, and you ask yourself, what is our dependent? What is our independent? When you grow older, you tend to have blood pressure. So we're saying blood pressure, it depends on what? On age. So what's our dependent variable? Blood pressure will be what? Our dependent variable. Our age will be what? Our independent variable, because age doesn't depend on blood pressure. So it's independent. Right, there's somebody who has raised the hand at the end. I don't know who is that person because on Zoom it's given another name. You can go ahead. I don't know who has raised the hand.
Say I'm not seeing anything.
Yes, I'm not sharing any screen right now because there's somebody that asked a question, how do you determine the dependent variable? How do you determine the independent variable? So I was giving an example that blood pressure and age, those are two variables, right? So blood pressure, it depends on what? On age, right? So that means blood pressure is our dependent variable in this case. But it's not always the case that blood pressure is what? It's a dependent variable. But in our case, in this case, we've got blood pressure not and age, right? So age will be what? Our independent variable. Any other question? Any other question? If you've got a question, you can put it on chat. Okay, somebody says on question 5 it's not stated. Which tutorial is that? But I'm sure it's given to you. It's given X and Y. If you've read the notes, if you follow the X and Y, right? If you follow the notes, you realize that the right hand model is Y is equals to beta naught plus beta 1. So tutorial 2. Okay, let me go to tutorial number 2. Tutorial number 2, question number 5. Yeah, but all I'm saying is if you've been reading the notes, you would understand that the equation, or it's Y is equals to beta naught plus beta 1 x1. So whatever is on the left-hand side, that's our dependent variable. Y is always our dependent variable in this course. So Y will be dependent variable and X will be independent variable. So any other question? But this will not be examined. So what will be examined is the outputs. All right. So you may be given an output on correlation, and you're told comment on the correlation coefficient, or that means you have to pick the correlation coefficient from that table and then interpret it. So this practical side, you have to practice by yourself. Any other question? If there is no question, we'll end here. And I waited for people to come to the tutorial on Monday, and only one guy showed up. And I don't know what happened to you other guys. Your class is almost 200 and something, and it's up to you. I'll be available during the lecture times, but not outside the lecture times. So I'm always available during the lecture times that we agreed, which is Monday, 2 to 4 p.m., then Wednesday, 2 to 4 p.m. It's unfortunate today, I'm sure there was an issue that came around that Dr. Mshanyo I'm sure he's teaching class 2. You need to one out. You need to have a lecture today. Someone says, which one is a constant? Beta naught or beta 1? Okay, let me go back to what you understand. The equation at high school that you used to call y is equals to mx plus c. You can write it down so that you can understand. Right? What was c? C, that is an intercept, which is also known as what? A constant, because there is no variable with itself, with that constant, right? It's any number. C, it might be 2, it might be 3. So an intercept might be 2 or 3. So that's our constant. So in our case now, we have got y equals to beta naught, right, plus beta 1 xi or x1 or just x. So beta naught, that's the constant. Beta 1, that's the slope or the gradient. I think Dylan, you answered, right? Then another question. I'm waiting for other guys if there's still a question. So if there are no more questions, we are done for today. So enjoy the rest of your day.